Hey everyone, Andrew Stormer here, and welcome back to my computer tutorial series where I teach you everything you need to know about speccing your own gaming or YouTube video editing build. Today we're talking RAM, and RAM is actually one of the more simple pieces of a computer, at least in the spec aspect of things. What does RAM stand for? RAM stands for Random Access Memory. And what it does is it holds a big chunk of information from a hard drive. It keeps it easy to access, unlike a hard drive, and it doesn't store it, it just keeps it easy to access. So then when the CPU needs something to process, it can bring in the next thing from the RAM. So it's like everything that the computer thinks it might need to process is in the RAM over here, and then when the CPU actually does need it, it can draw it super quick instead of like hard drive where it's a lot slower, it has to go find it and whatever. There's a few types of RAM. The most common these days is DDR3 and DDR4, and R3 at this point is pretty much dead. Except older builds, you'll still see it, but if you're building something new, R3, I wouldn't go with it nowadays. Sticking with the principles of things, though, that the newer the RAM, the faster it's going to be. But there are exceptions, which I'll get to in a minute. DDR4 and your speed both have to match your motherboard, which link up there to the video I did on motherboards. It has to be compatible with your motherboard. You think that the higher the speed your RAM is, the faster your RAM is. Wrong, because you have CAS latency, and CAS stands for, I have a little cheat sheet down here, it stands for column access strobe, and my note says it's the delay between a memory controller that tells the memory module to access a certain memory column on a RAM stick. When the data from the given array location is found, it can be accessed on the stick's pins. In English, what that means is your RAM stick, it has all your data in here. The CPU requests a certain piece of data, so then it has to go find it in the RAM. And then once it finds it, it pulls it from here and brings it over to the CPU. Latency is the delay that it takes to send the data over to the CPU. A zero latency piece of RAM is dang fast, because that means the instant it requests it, it's there. If you go over to this slider right here on PC Part Picker, a 22 latency, that's a pretty big latency. And this is where you can calculate how fast your RAM actually is. If you grab a calculator here, what you're gonna do to figure out the speed of your RAM is you're gonna take your latency and divide it by your speed. So if you look here, let's just take this top one right here. It has a 15 latency. We're going to divide that by 3,000, and you're going to get a 0.005. This is how many seconds it takes to find in the RAM what it wants. This is an okay piece of RAM. It's not the fastest out there, but they definitely do get a lot worse. There's a lot of 0.006 and even slower out there, and you don't want that at all. You're aiming for more of like a 0.004 in your RAM, so just go through the calculations, and that's the biggest thing that you're gonna pay attention to when choosing your RAM is your speed, and that it's compatible with your motherboard, and then the latency and figuring out how fast it is. A few last things here really quick that don't matter as much, but I can still mention is that the pins here, that's how many pins. This usually goes with like an R3 or an R4 automatically, but with laptops, they do have a different size and different pins and layout and whatever. I never end up getting into this, but that's a thing that's there. Voltage, I never get into, I don't care about it. ECC, this is a thing if you're doing like a workstation or server, you might want ECC RAM, which ECC is error correcting code. And what that means is that somehow the the RAM actually detects if it copied information from a hard drive wrong, and it goes back, it finds that it's wrong, and it corrects it. So where usually if your CPU processed that wrong information, it would be a corrupt file and it might even crash your computer. But ECC, what it does is it detects that it's false and then it replaces it with what's right. So it fixes corrupted files in the RAM, and then you're not going to have a crash. The catch is it's not usually good for gaming. It's also usually slower. So this is only good for workstations and servers. This RAM, you can see it's all exposed, all the memory chips are exposed, but a heat spreader, it's like this, where it has a casing around it and it spreads out the heat from those individual chips on the stick. And if you want to go crazy, sometimes you have stuff like this, where this is another heat sink with fans on it, and that just clips right over your like 4 sticks of RAM or whatever. So this one right here, it has all these heat spreaders and stuff all in it already, and then you can stick this thing on it that has fans. If you want to overclock your RAM, you might want to look into one of these, but I think it's overkill. I just say get anything like this where it's just anything that covers it. I wouldn't get anything exposed like this, except if you're doing some huge workstation or server that you're throwing 500 gigs of RAM into, then this might be the only way it comes. And then some of those heat spreaders too, it makes it look nicer, and some of them have LEDs, so if you want to do an RGB build, you can make your RAM light up, and it's kind of cool. Timing, you really don't have to pay attention to if you just get all the same RAM, but if you do want to add RAM to your computer in the same parallel slots in your motherboard, but they aren't the same stick, timing you have to pay attention to. So in a motherboard, let's just say you have 2 black slots and 2 blue slots here. And those slots, they have to be equal. The easy way to go is just throw all the same in all the different slots. If you happen to not be able to get the same exact stick, you might is the key word, be able to get a RAM stick that has the exact same timing as what's already in there, and then put them in the same parallel slots, and then it might work. So that's an option for you there. That's it with RAM. There's some things that you might need to look into if your motherboard is compatible with it. And like I said earlier, go watch the motherboard video that I did. And the main thing you're gonna wanna remember is that calculation of your latency divided by your speed, and that is your overall speed of your sticker RAM. So thank you all so much for watching, and I'll see you next time.